Greetings and salutations, and welcome back to 1 Lesson 3 Math. While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home, as it will hopefully enhance your mathematical understanding. The learning objective of this video is to be able to apply Pythagoras' theorem and or trigonometry to different scenarios to find missing lengths. So we've got an exam style question here where it's not immediately obvious what we've got to do besides calculating x. BACD is a rectangle, quite clearly, and obviously, as I've said, we need to calculate x. So there's a lot of things at play here that we need to do to find the value of x, and actually there's several different methods that we can use. But if you want to have a go at this question, please pause your video now before I go through the solution. So when I'm dealing with finding a missing side, I immediately look and see if I can find a right-angled triangle. And then if I've got two of the measurements, that means I can use Pythagoras, or if I've got an angle within the triangle and another side, then I can use trigonometry. But at the moment, I don't have an angle within the triangle with the hypotenuse, the yellow line that I've just added to the diagram. So I'm going to have to try and calculate that line, the diagonal AC. So what can I do to find that? Well, I've got information that one angle is 54 degrees. I can possibly use that to find the length of the red line that I've just drawn. So I'm thinking maybe trigonometry at this point. So how could I do that? Well, I've got this triangle here, and I know that the base of this triangle is going to be 9 centimeters because it's half of 18. Now, I've drawn an angle BAC, and I can work out that angle because the triangle here that I'm just hovering over is an isosceles triangle. So basically, my calculation to find the angle that is going to be an alternate angle to the angle ACD is going to be as follows. So there's my triangle. Now it's 180, take away 54, divided by 2, because obviously it's an isosceles triangle. So that angle is going to be 63 degrees, and therefore the angle down here is also going to be 63 degrees, because alternate angles are equal. So we've got an angle now, and we've got a side, so that allows us to use trigonometry. So I'm going to label the sides accordingly. Longest side is the height, the opposite side is the opposite, and the side that has the angle and the right angle is the adjacent side. So I'm going to look at which two sides are involved. Now, as I said, we need to find, if we find the red line, that means we can double it to find the length AC. Consequently, we're going to use the hype and we're going to use the adjacent. We write down SOHCAHTOA. We cross out the opposite. So we're not using SO and we're not using TOA. So we are using CA, which is cos x equals adjacent over hypotenuse. So I start subbing in my values. I've got cos 63 equals 9 over the hype. And my motto when we are finding the one on the bottom, in this case the hype, when you don't have the one on the bottom, you swap them. So we can swap cos 63 with the hype, and that will allow us to calculate the hype as follows. 9 divided by cos 63 equals 19.824 centimeters. Now, one piece of advice here is not to round too early. I've gone to 3 decimal places. So now what I can do is I can say, well, does that seem like a reasonable answer, first of all? Well, yes, it does. It's going to be longer than 9. It seems like it's a reasonably close answer to make that triangle realistic. So 19.824 centimeters is fine. So now I'm going to double that to calculate CA, and that's 39.648 centimeters. So now I've got this right-angled triangle where I've got two sides. Now obviously when you've got two sides, it becomes, to find the other side, a Pythagoras problem. So I'm going to label the sides CBA. C is the hypotenuse, A and B are interchangeable. I'm going to write down Pythagoras' theorem, ABC squared 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 plus equals, and I'm going to substitute in the values. So I've got 18 squared plus B squared equals 39.648 squared. So B squared, I'm going to subtract 18 squared from 39.648 squared. B squared equals 1247.9962. Then I need to square root that. That gives me B equals 35.3269, and rounding that to two decimal places and calling it X because that's what we're asked to calculate. It's 35.33. The 2 rounds up because of the 6 next to it. So that would be one way of doing it. And actually that's a little bit of a more challenging way of doing it. You could have just used trigonometry to find the opposite, going back to this red triangle. So if we'd used adjacent and opposite, it would have been TOA. We could have used tan x equals opposite over adjacent to find the opposite, and then we could have doubled that measurement to find x. It would have given you the same answer. You can try it if you would like to, but you know, as I often say, in maths, there's many different ways of solving problems, and as long as you pick a suitable one and show all of your working out and then get the right answer, then everything's fine and dandy. So, thank you for tuning in to 1 Less Than 3 Maths. Have a good Easter. It's Easter at the moment, and if it's not for you when you're watching this video, then have a good Easter the next Easter that you have. Okay, all the best. Ciao. Hasta la pizza, arrivederci, so long, goodbye.